For generations we've looked up at Mars as a symbol of desolation, a silent, rusty globe hanging in the cosmic dark. It was the stuff of science fiction, a place of ancient failed civilizations, or more commonly, just a vast empty wasteland. We saw a world entombed in red dust, its surface cratered and still, a celestial tombstone marking the death of a world. Its thin atmosphere offered no comfort, its polar caps of ice seemed like frozen monuments to a forgotten time. This was the Mars of our early explorations, a planet that had seemingly given up its ghost billions of years ago, leaving behind nothing but a cold, rocky corpse for us to study from afar. This image was powerful. It shaped our perception and our expectations. We sent our first probes, the Mariners and Vikings, and they sent back pictures that confirmed our suspicions. We saw endless fields of red rocks under a pale pink sky. There were giant silent volcanoes and canyons so vast they dwarfed anything on Earth, but they were all static, frozen in time. The silence was deafening. Where was the life? Where was the action? The universe, it seemed, had passed Mars by. The planet was a museum piece, a perfectly preserved example of what happens when a world loses its vitality, a cautionary tale written in rust and rock across an entire celestial body. This view of Mars as a dead world became deeply ingrained in our collective consciousness. It was the control group in our solar system's experiment of life. Earth was vibrant, teeming with activity, a riot of color and sound. Mars, its next-door neighbor, was the opposite, monochromatic, silent, and sterile. The stark contrast made Earth seem all the more precious, a unique and fragile oasis in a vast, uncaring cosmos. We thought we understood Mars's story. It was a world that was once perhaps a little like Earth, but it failed. It lost its water, its air, its warmth, and with it, any chance it ever had at hosting life. It was a cosmic tragedy, but one that was long over. But the universe is rarely as simple as it first appears. It's full of secrets, hidden in plain sight, waiting for the right tools and the right questions to be asked. As our technology grew more sophisticated, so did our ability to listen to the faint whispers of the cosmos. We started to look at Mars not just with cameras but with spectrometers, radars, and seismometers. We began to peel back the layers of red dust, to look beneath the surface, and to analyze the very air it breathed. And what we started to find was not the story of a dead planet, but the story of a planet that is hiding its secrets. A world with a complex past and a surprisingly dynamic present. The silent, empty wasteland was beginning to talk. Then, a new vision for Mars began to take hold. It wasn't just a place for scientists to study from a safe distance, it was a destination. People like Elon Musk started talking about Mars not as a graveyard but as a frontier, a place for humanity to build a second home. This idea, once confined to novels and movies, suddenly felt tangible. Musk's vision is bold: to create a self-sustaining city on Mars, to make humanity a multiplanetary species. This isn't just about survival, it's about adventure, exploration, and the expansion of life itself. It's a dream that forces us to look at the red planet not for what it is, but for what it could become. This grand ambition required a complete shift in our thinking. If you want to build a city on Mars, you can't just see it as a pile of lifeless rocks. You have to look for resources. You have to search for water, for minerals, and for any advantage the environment might offer. Suddenly, every new piece of data from Mars was viewed through this new lens of possibility. This dream of colonization is a powerful motivator. It fuels innovation, pushing us to develop the rockets, life support systems, and habitat technologies that would be necessary for such an incredible journey. The dream of living on Mars makes us study it with a new intensity, because our future might one day depend on it. NASA, too, began to share in this revitalized vision. While perhaps more cautious, the space agency's goals aligned with this new era of Martian exploration. The mantra became, "Follow the water." NASA understood that where there is water, there is the potential for life, both past and present. And for future human explorers, water is everything. You can drink it, you can use it to grow plants, and you can even split it into hydrogen and oxygen to make rocket fuel. The search for water became the central pillar of modern Mars exploration, transforming the planet from a subject of purely academic interest into a target of immense strategic importance for the future of humanity. The dream of a Martian frontier and the scientific quest for life are two sides of the same coin. They both drive us to dig deeper, to look closer, and to challenge our old assumptions. Elon Musk's rockets and NASA's rovers are partners in this grand endeavor. One provides the vision of what could be, while the other provides the scientific evidence of what is and what was. Together, they are rewriting the story of Mars. The planet is no longer just a distant red light in the sky. It is a world of possibilities, a place where humanity's most audacious dreams might one day take root and grow, transforming the silent wasteland into a new branch of the human family tree. The biggest clue that Mars was not always a desert came from looking at its surface with new eyes. Our orbiters, equipped with powerful cameras and altimeters, began to map the planet in stunning detail, and what they revealed was unmistakable: the ghost of a watery world. We saw features that were incredibly familiar to us here on Earth. There were vast meandering channels that looked exactly like dried-up riverbeds. Some of these ancient rivers emptied into enormous basins, creating deltas, fan-shaped deposits of sediment that form when a river meets a large body of still water, like a lake or an ocean. These were not just cracks in the ground, they were the clear signatures of flowing liquid water on a massive scale. The evidence continued to mount. We discovered vast northern plains that are incredibly flat, much flatter than the cratered southern highlands. Scientists now believe these plains were once the bottom of a huge ocean that covered nearly a third of the Martian surface. Imagine that, a Mars with a great northern sea, under a thicker, warmer sky. We have even found what appear to be ancient shorelines, marking the edges of this long-lost ocean. Our rovers, like Curiosity and Perseverance, have driven across the floors of what were once deep lakes, finding layers of sedimentary rock that could only have formed at the bottom of a body of water over millions of years. These rocks tell a story. They contain minerals like clays and sulfates that only form in the presence of water. It's a chemical fingerprint left behind by a bygone era. We're not just guessing that Mars had water, the planet's own geology is screaming it at us. The evidence points to a Mars that, billions of years ago, was a much more Earth-like place. It had rivers carving canyons, lakes filling craters, and possibly a vast ocean shimmering under the faint young sun. This wasn't just a little bit of water, it was a complex and long-lasting hydrological cycle, a world that had all the right ingredients for life as we know it to emerge. So the question is no longer if Mars had water, but where did it all go? The transformation from a wet, potentially habitable world to the cold, dry desert we see today is one of the greatest mysteries in the solar system. Understanding what happened to Mars is not just about understanding another planet, it's about understanding the delicate balance that allows a world like ours to thrive. The story of Mars's lost water is a cosmic detective story, and we are the detectives, piecing together clues written in the channels, canyons, and ancient lake beds of a world that once held the promise of being Earth's twin. The story of Mars's transformation from a warm, wet world to a cold, dry one is a tale of loss. The prime suspect in this planetary mystery is the loss of its atmosphere. Billions of years ago, Mars had a much thicker blanket of air, probably rich in carbon dioxide. This atmosphere created a greenhouse effect, trapping heat from the sun and keeping the surface warm enough for liquid water to flow freely. It was this thick atmosphere that made the ancient rivers and oceans possible. But over time, that protective blanket began to unravel, and as it thinned, the planet's ability to hold on to its warmth and water vanished with it. The air literally escaped into space. So what caused this great atmospheric escape? The culprit was the loss of Mars's global magnetic field. Here on Earth, our planet's molten iron core generates a powerful magnetic field that surrounds us like an invisible shield. This shield, called the magnetosphere, deflects the solar wind, a constant stream of charged particles flowing from the sun. Without this protection, the solar wind would slam into our atmosphere and strip it away, layer by layer. Mars, being smaller than Earth, cooled down more quickly. Its iron core solidified, the dynamo that generated its magnetic field shut down, and its protective shield vanished. Once its shield was down, Mars was left vulnerable. The relentless solar wind began to erode the Martian atmosphere, carrying its gases away into the void of space. NASA's MAVEN, or Mars Atmosphere and Volatile Evolution Orbiter, was sent specifically to study this process, and it has confirmed that this atmospheric stripping is still happening today, albeit at a much slower rate. MAVEN has measured the gases escaping from the top of the Martian atmosphere, and has shown that during solar storms this process accelerates dramatically. Over hundreds of millions of years, this steady erosion was enough to turn a planet with a thick protective atmosphere into the near vacuum we see now. With most of its atmosphere gone, the air pressure on the surface of Mars dropped dramatically. It fell so low that liquid water could no longer remain stable on the surface. Any water would either freeze into ice or boil away directly into vapor. The planet grew cold and arid. The rivers stopped flowing, the lakes dried up, and the great northern ocean disappeared, leaving behind the vast empty plains we see today. The story of Mars's lost atmosphere is a stark reminder of how fragile a planetary environment can be. It shows how the fate of a world is tied to its deep interior, and how the loss of an invisible shield can lead to the death of a world's surface. Just when we thought the Martian surface was completely dry, the planet surprised us again. High-resolution images from the Mars Reconnaissance Orbiter revealed something extraordinary: dark streaks appearing on certain crater walls and steep slopes during the warmest Martian months. These features, called recurring slope linei, or RSL, would appear in the spring, grow longer down the slopes in the summer, and then fade away in the autumn and winter, only to reappear the following year. They looked for all the world like streaks of damp sand, as if something was seeping out of the ground when the temperature rose just above freezing. This discovery was electrifying. Could this be evidence of liquid water flowing on Mars today? The locations of these streaks were on sun-facing slopes where temperatures could climb high enough to melt ice. However, pure water would quickly boil away in the thin Martian air. The leading theory was that this water must be incredibly salty. Salts, like perchlorites, which are known to exist in Martian soil, can lower the freezing point of water significantly. This would allow a salty brine to remain liquid at much colder temperatures and evaporate more slowly, long enough to create the dark streaks we see. The idea of liquid, briny water on present-day Mars opened up a whole new realm of possibilities for life. While these brines would be far too salty and cold for most earthly life, we know that here on our own planet, some hardy microorganisms called extremophiles can thrive in incredibly harsh, salty environments, like the briny pools of Antarctica or the hypersaline lakes of the Atacama Desert. If life ever got started on Mars, perhaps it retreated to these small, temporary pockets of salty water as the planet dried out. These seasonal seeps could be modern-day oases, tiny refuges where microbial life might be clinging to existence. However, the mystery of the RSL is not yet solved. More recent research has suggested that the streaks might not be caused by flowing water after all, but by flows of dry sand or dust. The debate is ongoing, a perfect example of the scientific process in action. But whether the streaks are wet or dry, they show us that Mars is not a static, unchanging world. It is a place of active geology and seasonal cycles. The very existence of this debate forces us to consider the incredible possibility that liquid water, the essential ingredient for life, might still be found on Mars today, even if it's just a fleeting, salty trickle down a crater wall. While the surface of Mars offered tantalizing but ambiguous hints of water, the most stunning discovery came from looking deep beneath the ground. Using a ground-penetrating radar instrument called MARSIS on the Mars Express orbiter, scientists scanned the planet's south polar ice cap. For years they sent radar waves down through the thick layers of ice and dust, listening for the echoes that bounced back. In 2018 they found something that made the world take notice: a patch of intensely bright radar reflections about 20 kilometers across, located a mile and a half beneath the polar ice. This was not the signal they would expect from solid rock or ice. This bright reflection was consistent with only one thing: a large body of liquid water. Scientists believe they have found a subglacial lake, much like Lake Vostok, which is buried deep beneath the ice of Antarctica here on Earth. The immense pressure from the ice cap above, combined with salts dissolved in the water, could keep the water in a liquid state despite the incredibly cold temperatures. This discovery was revolutionary. It suggested that a significant reservoir of liquid water, the first of its kind ever found on Mars, might be hiding right under our noses, protected from the harsh surface environment. The significance of a subglacial lake cannot be overstated. On Earth, subglacial lakes are teeming with microbial life. These ecosystems are completely isolated from the outside world, surviving in total darkness and crushing pressure, feeding on chemical nutrients from the surrounding rock. If there is a similar lake on Mars, it would be one of the most promising places in the entire solar system to search for life. Protected from the deadly solar radiation and extreme temperature swings of the surface, this hidden lake could be a stable, long-lived habitat where life could persist or even thrive, completely unaware of the desolate world above. Since the initial discovery, scientists have found evidence of even more pockets of potential briny water scattered around the main lake. This suggests that the south pole of Mars might host a whole network of underground lakes and slushy, wet sediments. There is even the possibility that geothermal heat, warmth seeping up from the planet's interior, could be helping to keep these areas liquid. This idea challenges our view of Mars as a geologically dead planet. It hints at a world that still has some warmth left in its heart, providing the energy needed to sustain liquid water and just maybe a hidden biosphere deep beneath its frozen surface. Our journey to understand Mars is a journey of listening. We started by seeing a silent world, but as we built better ears, better instruments, we started to hear its story. The Perseverance rover, our most advanced robotic geologist, is listening right now in a place called Jezero Crater. This crater was not chosen by accident. Billions of years ago, it was a deep lake, fed by a flowing river that built a magnificent delta. Perseverance is exploring this ancient lakebed, analyzing the rocks for biosignatures, the chemical fingerprints that ancient microbial life might have left behind. It's drilling core samples of the most promising rocks and sealing them in tubes, leaving them on the surface for a future mission to collect and return to Earth. This mission is a pivotal moment in our search for life beyond Earth. For the first time, we are not just looking for habitable environments, we are actively searching for the fossilized remains of alien organisms, and the science continues to evolve. Recent studies suggest that the briny subsurface water on Mars could hold enough dissolved oxygen to support aerobic microbes, organisms that breathe oxygen, just like animals on Earth. The cold temperatures and high salt content would allow oxygen to dissolve into the water much more easily than previously thought. This opens up the tantalizing possibility that a Martian ecosystem could be far more complex than we ever imagined. At the same time, we're learning about the threats Mars poses. We've witnessed planet-encircling dust storms that can blot out the sun for weeks, a major challenge for future solar-powered colonies. Through our InSight lander, we've listened to the planet's heartbeat, detecting Marsquakes and the thud of meteoroid impacts. These seismic waves have given us our first glimpse into the planet's internal structure, confirming it has a large, liquid core. We are piecing together the puzzle of Mars from its core to its escaping atmosphere, building a complete picture of a world that is far from dead. Mars is revealing itself to be a world of hidden truths. Beneath its rusty, desolate surface lies the ghost of a blue planet, the promise of hidden oases and the faint possibility of life. It's a world that lost its past but may have a vibrant future. The story of Mars is not over. In a way, it may be just beginning. As we continue to listen, to explore, and to dream, we may find that our own destiny is intertwined with that of the red planet. Perhaps humanity's role is not just to be a visitor, but to be the force that helps revive Mars's story, bringing life back to a world that has been waiting patiently for billions of years.